The dialysis circuit, part 2. Hemodialysis devices, the Dialysate delivery system, consisting of the proportioning system, conductivity adjustment, temperature control, ultrafiltration control to the desired amount, dialysate flow rate, and blood leak detector. The dialysate proportioning system ensures proper mixing of the treated water with dialysate concentrate to prepare a dialysate of correct proportion, correct temperature, and conductivity within a specific physiologic limits. This happens by means of proportioning pumps and concentrate. The proportioning system mixes concentrate and water. Water inflow from the water treatment system pass through a heater, then mix it by a concentrate of an acid and a bicarbonate. Then we have a concentrate and water mix. Pass through the conductivity and temperature monitors. Controlling the dialysate flow, then passing the dialysate flow to the dialyzer through a volumetric control system to adjust the desired ultrafiltration rate. When packed from the dialyzer, the dialysate passed through a blood leak detector. The dialysate delivery system. The final dialysate is checked for proper mixing by measuring the conductance of electricity through the final dialysate. The basis of that, the rate of flow of an electric current through any solution is proportional to the concentration of electrolyte present in that. So the salt solution is a good conductor. Rate of electrical conductance, the concentration of salt in the solution can be verified. Roughly, it could be estimated that the conductance is about 1/10 of the sodium concentration. Thus, a dialysate of around 135 milliequivalent per liter sodium concentration should have a conductivity value of 13.5. Purification of the inflowing dialysate system to produce an ultra-pure dialysate is essential when treating patients with high flux dialysis, and we have to ensure a sterile dialysate when we are using a hemodiafiltration therapy. Endotoxin filters are used in this purification. At least one endotoxin filter is essential to produce ultra-pure dialysate. for high flux dialysis. When water is coming from the RO system and pass through the concentrate, acid and base for mixing, then have to pass through an endotoxin filter, removing the endotoxins. While when you are using hemodiafiltration, double endotoxin filtration is essential to produce a sterile fluid for infusion. Only one endotoxin filter is required for high flux dialysis. At least one. But two endotoxin filter, at least two, is required for hemodiafiltration therapy. So in case of hemodiafiltration, at least two endotoxin filters to ensure that the dialysate had passed through both of them to ensure a sterile fluid for substitution. From the acid and the base mixing to the dialysate, pass through endotoxin filter 1 and 2. Potential problems in hemodialysis dialysate delivery system could harm the patient, including incorrect bicarbonate or acid concentrate, changing the pH of the fluids, inadequate dialysate mixing, clogging in the filters, device alarms disarmed by the operator, precipitation of calcium or bicarbonate salt inside the hemodialysis machine. Hemodialysis machine alarms, temperature and pressure monitor, temperature monitor. A malfunctioning heating element can cause abnormal dialysate temperatures. Cool temperature will result in shivering. Warm temperature can cause protein denaturing or hemolysis. The pressure monitor. The range is from negative 400 to positive 350 millimeter mercury. Alarm limits are set at plus or minus 10% of the pressure setting. Ultrafiltration is controlled by a transmembrane pressure. The transmembrane pressure, maximum pressure, is around 500 millimeter mercury. Otherwise, dialyzer fiber rupture can occur. Air detector on the terminal part of the venous line located along the return line and is activated by air in the blood and microemboli. When alarm is initiated, there is clamping on blood return side to prevent air embolization. An essential safety step. Blood is coming from the dialyzer, can have micro air emboli. Moving to the air detector, device, alarm, and automatic clamping to prevent air to move through the line to the patient. Air detector will induce 3 steps: producing alarm, stop the blood pump immediately, and the clamp on the blood return. Air detectors. When air or foam detectors continuously check the blood in the venous tubing system for air and foam, either the system can check for air at the venous drip chamber or at the blood tubing just below it. Air detectors are ultrasonic devices that check for changes in a sound wave sent through a cross-section of the blood path. The reason for that, sound travels faster than air, than liquid. When the air detector senses air, it will trigger an audible and visual alarms. Stop immediately the blood pump and immediately clamp the venous blood tubing to keep air from getting into the patient bloodstream. The ultrafiltration control system in the hemodialysis machine depends on the transmembrane pressure and the dialysate pressure. It determines how much fluid from the blood is forced across the membrane. The amount of fluid removed in a specific period of time is the ultrafiltration rate. Most dialysis machines use a system called a volumetric fluid balancing system. The volumetric balancing system have two balanced chambers, which are identical chambers. Each chamber is divided in half by a flexible diaphragm. Each chamber half has an inlet and an outlet. One side of each chamber is in the 2D dialyzer or the fresh dialysate flow pathway, and the other side is from the dialyzer or used dialysate flow pathway. Controlled by an ultrafiltration pump. This ultrafiltration pump controls how much negative pressure is required to achieve the desired ultrafiltration rate. The second ultrafiltration control system is the flow sensor ultrafiltration, which depends on a flow control system based on flow sensor locate on both the inflow and the outflow of the dialysate. Inflow sensor and outflow sensor. This controls the rate of inflow and outflow pumps to achieve a balance. A separate analyzer system can guide an increase in the transmembrane pressure to act as ultrafiltration pump, which can remove excess fluid before the spent dialysate pass through the outflow sensor. We have inflow sensor, outflow sensor, analyzer adjusting the transmembrane pressure. Transmembrane pressure monitor. In the blood compartment of the dialyzer, a positive pressure is created when the blood is pumped into the narrow fibers. In the dialysis fluid compartment, there is usually, when a low flux dialyzer with a low dialyzer KUF is used, a negative pressure is required and created by a suction pump called the ultrafiltration pump in the hemodialysis machine. The pressure gradient across the membrane created by the pressures in the two compartments, the blood and the dialysate compartment, is called the transmembrane pressure in mmHg. Transmembrane pressure monitor. The maximum can be achieved is around 500 mmHg. Otherwise, the fiber can rupture. It's calculated internally inside the hemodialysis machine system by two forces, the blood force and the dialysate force, controlling the pressure of the blood inlet and the pressure of the blood outlet. So we have the mean, as well as the pressure of the dialysate inlet and the pressure of the dialysate outlet and the mean. Ultrafiltration depends on the treatment modality, the blood flow, the dialysate flow, and the pressures. The dialyzer specification. Dialyzer related parameters include flow resistance, dialyzer hydraulic permeability, KUF, and the filter fiber geometry. Either low flux with very low limited KUF and a high flux dialyzer with higher ultrafiltration. Some patient parameter can control as well how much fluid is removed. Blood composition with regards to hematocrit and the plasma protein concentration. Increase oncotic pressure needs higher transmembrane pressure to achieve the ultrafiltration rate. As well, how much ultrafiltration volume required for each patient. Transmembrane pressure will be increased if dialyzer clotting happened, increase in the venous pressure, or a very high ultrafiltration rate is required with a low dialyzer KUF. All these parameters controlling how much transmembrane pressure is applied and is monitored on the hemodialysis machine. The ultrafiltration coefficient of the dialyzer. This is the efficiency of the dialyzer. How easily the fluid moves through a given membrane. It's also known as the membrane hydraulic permeability. It is the relationship of volume removed to pressure applied. Thus, it's measured in milli per hour per millimeter mercury of pressure. The ultrafiltration coefficient of the dialyzer. When blood is passing through the narrow fibers, a positive pressure in the arterial and venous side induces ultrafiltration. Against that is the plasma oncotic pressure, which prevents ultrafiltration. The hemodialysis machine has an ultrafiltration controller. Negative pressure is applied according to the dialyzer KUF and the ultrafiltration rate required. Moving of the blood, filtering the excess fluid required depends on the dialyzer KUF. Low flux dialyzers needs high transmembrane pressure as the KUF is low. Hemodiafiltration has very high transmembrane pressure as the ultrafiltration rate is extremely high. In high flux dialysis, the ultrafiltration rate as a function of the transmembrane pressure is not almost linear. We have here the average ultrafiltration rate relation to the pressure. So at a certain point of high transmembrane pressure, we cannot find the linear relationship with increasing the ultrafiltration rate. Finally, the blood leak detector. Blood should not cross the blood dialysate membrane. Leakage of blood into the dialysate circuit is detected by the blood leak monitor, which is usually located downstream from the dialyzer. Depending on a photoelectric cells, which detect decreases in light from the source. Red blood cells scatter light and trigger the alarm, which completely deactivates the blood pump flow. And photoelectric cells, while dialysate is flowing, if red blood cells is found, it will initiate the alarm. Thank you very much.